Hello, everyone. So we'll just get started then. So there are quite a few of us. Should we all just introduce ourselves? I think we might as well get that out of the way. But I am Katherine Druckman. I am an open source evangelist at Intel. And I will be handing this mic over to a few of my colleagues and one of our friends from another company. But we'll get to them later. But first, so we're going to go into a hands-on workshop. But first, I just kind of want to give you an overview of why we're here and what we're even talking about. What is this OPEA project thing that we should care about, and why? So, oops, hi. So here's our premise, right? AI is very exciting. Who here is not excited to build a generative AI application? Possibly you've been mandated to build a generative AI application. Or maybe you're just doing this because it's exciting and fun and you want to be a pioneer and camp out on the frontier. But what happens when we are all very excited about this new technology and at a technical inflection point, we are very focused on rapid innovation. We are focused on a goal. We're trying to get a minimum viable product out the door, probably. Getting some basic functionality. And again, especially in pioneering fields, what's sometimes lost in that drive to get something out the door, to start tinkering, start building, is the foresight to apply principles that lead to interoperability and flexibility that will save you time and money and resources and all sorts of things down the road. So these are things that we want to really focus on. And again, in emerging fields where we have not, as a community, as individuals even in many cases, established best practices for doing a thing, or modular architectures and interoperability that has not yet been established, the lack of established best practices and standardization slows us down. It slows down our development processes. AI development is kind of like the Wild West. Everyone's reinventing the wheel, and we're kind of doing that in silos. We're doing it in our own teams. We're not necessarily coming together, benefiting from the open source way of doing things to collaborate on a best practice. So what we would like to see in this project, which I'll get a little bit more into, but it is a Linux Foundation project. What we'd like to see is adoption of these community established standards to smooth and speed up everyone's development workflows. Because again, that's the open source way. We come together and we figure it out. I suspect, being that we are at Open Source Summit, we are all open source people here, I hope we are. And this, again, is the open source way and the vendor neutral way. But again, what happens when we get excited about pushing those technology boundaries? As much fun as we might be having, making cool new stuff, we tend to focus on that goal and getting there by any means necessary. That can mean we are, again, constantly reinventing the wheel, and we're breaking ground quickly, a lot of new ground. And there are a lot of different options and paths to reach the same goal. We've been handed this giant pile of generic Legos. This is not a kit for building the Eiffel Tower, right? This is a pile. We don't necessarily know what to do with it. And so we don't, again, have the luxury of forging a path of those who have gone before us. And because we have so many options, we may end up like this disorganized pile of Legos. Without a reproducible way of working, which becomes very important down the road once you have something working. And again, as a community, I think we can do better. So this little monster here is our current minimum viable product that we rushed out the door. It works. It maybe even works well. But how do you make modifications to it? It might bite you. It might be tough to expand. It might be tough to maintain. You probably want to start with something more solid. What if you want to change and use a different vector database down the road? What if you want to change your framework? I don't know, change anything about your application. If we had started with something a little bit more orderly, we might not have created this monster. But we've been there, right? It works. We probably had a really good time building it. But it might have a mind of its own. So again, with the struggles and that organizations and developers face under the pressures of that rapid innovation, it might be tempting to take the proprietary path, but we absolutely do not need to. The good news is that the open source community is coming together, like we always do, to solve the tough problems. And in this case, we're doing it under the umbrella of the Linux Foundation to work toward that standardization I keep harping on. We're working on an interoperable, vendor-neutral platform that helps us tame this chaos. And that is the Open Platform for Enterprise AI, which is what we're going to dive into here in a bit. As enterprises seek to achieve these AI goals, they're looking for simplicity, total cost of ownership savings, and being open is the key to all of that. It's the key to having the flexibility down the road. It's a key to being able to build something that serves both you and the end user and the business. Better collaboration, right? Things are not attached to any particular company. We get the support of the community by doing it this way. Each decision you make now affects how you develop in the future. And now is the time when you want to avoid that lock-in. When we deploy generative AI in the enterprise, things get a little bit chaotic with all of the moving pieces, and frankly, that pressure, that mandate to get something out the door. But as Easy will show us shortly, what if we could simplify that? And instead of having a pile of random Legos, what if it's a set? What if it's a little bit more pre-built, packaged nicely, and we have a predefined block that we can put together, but it's an informed and opinionated block. By doing that, again, we can treat each piece on its own. We can remove one, replace it with something else, and it gives us that framework. That's what OPEA is all about. It gives us a framework to make generative AI implementations more straightforward, more manageable, more interoperable. It just started. I think we've just passed our 1-year anniversary. So it's actually still a relatively young project. Great time to get involved. I am from Intel, Easy's from Intel, but this is not an Intel project. This is an open source community effort with quite a few folks working toward building it up and really hardening those best practices. So again, this is the problem that we're working together to solve. There is a ton you can build. We're going to build, I believe, a chat Q&A application, but there are over 20 example applications that you can dive into in the project repo. We encourage contributions, of course, like any open source project. We would love for you to join us. And if you don't find what you need in the repo, please work with us to create it. We would love to see some pull requests from different demos or different use cases, something maybe we haven't thought of as a project yet. And again, before I hand it off, I have to give a little shameless plug. I have this conversation a lot. I am a person who is interested in the intersection of security and AI quite a bit. I happen to also lead the security working group for the Open Platform for Enterprise AI project. I'd love to see you there. But I wanted to give a quick plug to the OpenSSF. They have a booth here. As we are pushing all of these boundaries and building all of these new things, I really want to drive home the importance of not letting security concerns fall by the wayside, which tends to happen sometimes when we get excited. Again, I would love for you to join me in the OPEA security working group to help answer these tough questions at that intersection of security and AI. So that's all I've got, and I will hand it off to our next person, and we will go deeper down the rabbit hole.
Yeah. Okay. So now for the exciting part. So if you have your laptops, please open it. All you need is the web browser, and I'll get you started with setting up AWS account. So we have some accounts provisioned for you, so you will be using that for this workshop. And you'll have access to it for the duration of the workshop, and also, I think, 1 hour after it, right? And then you will no longer have access. So let's get started. So what are we building today? So like Katherine was mentioning, so we will be building a OPEA RAG application. So this is just a schematic of all the blocks that we will be using. We will go into details later, but in general, this is the application. You can see that there is a LLM microservice here. Along with that, we will build like a RAG solution where it can take documents, and it will act as a Q&A application, right? So this is what we will be building. Some information about this workshop. So you will be getting access to AWS account that is pre-provisioned to build this solution, and then the account will be only will be available for the duration of this workshop. I think it's also available for 1 hour after the end of this workshop. And then, yeah, be sure to read the terms and service, and then please don't upload any of your personal or confidential information. So with that, let's get started. So if you're ready with your laptops, just open up a browser and then just search for workshop AWS login, right? So just search for that, and then the first link is what we will be clicking on, and then we will put in our email address and then get access to it. All right, so I'll do this alongside. So just Google, workshop AWS login. On the very first link should be this AWS Workshop Studio. Click on that one. And hopefully you get the screen which has these 3 options here to input your email address, right? So let me know if you want me to slow down at any point. Hopefully people are at this screen, right? So click on this first option where you can enter your email address, and you will receive an email with the code. So I will do this at the same time. I'll put in my personal email here. And then click on send passcode. And then you'll have to enter the code that you will receive. Yeah, I already got the email, so it should be pretty fast. All right, so hopefully people are at the screen, so I'll give it a second, and then I'll give you the code that you have to enter here. All right, so we did a Google search. We clicked on the first option to enter the email address, and once you enter the email address, it will give you a 9-digit code, which you will enter, and then you should have arrived at the screen where it's asking you for an event access code, and the event access code is right here.
Your video.
I don't know what happened. Okay. Okay, I'll do the same thing on my screen here. Okay, 1F96. Okay, so once you enter the screen, so you should be on the screen where you can read the terms and condition and then join this event. You should click on I agree with terms and condition after you read it, and then click on join event. Hopefully everybody's at this screen. Let me know if you want me to slow down here. So click on join event, and this should actually load the dashboard, and it will tell you that you have access for the next 3 hours here. Right. Okay, click on join event, and then you should be at get started with the workshop. Okay, and then at the bottom left, you will see that there is an option where you can click on this Open AWS Console. Go ahead and then click on that one. This should open up a new tab, and then it will load the console. Okay, so hopefully people are at this screen. So let me know how many of you are at this point here. Okay, quite a few. So I'll wait a few more seconds here. Anybody having issues? Need help?
Can you put up the access code again?
Yeah. Okay, again, once you enter the access code, you have to agree to the terms and condition and then click on join event. And then once you've joined the event, it should load a page, and on the bottom left-hand side, you will see a link to open up the console. All right, so once you open the console, this is the link to open up the console, open AWS console, and then you should arrive at the screen that you see on the right-hand side here, which should look like what I have here. Right, which shows you your instance here. And the next step here is on the top black bar, you do see a link to open up the Cloud Shell terminal. Go ahead and then click on this icon right here. And this should open up a console. And this is where we will be doing most of the work today. So we will be copying some code, scripts, and then we will be pasting it here. And this is what will eventually help you to build the entire RAG solution and deploy it. Right, so if you see this prompt here, I think you're all set to start the workshop. Anybody at this point here with the Cloud Shell open? Okay. Anybody having issues with the code? Yes?
It just says invalid access code.
Invalid access code. 1F960CD8FFF4. Yeah. Easy check if it's the East, US East. Okay, who else had issue with the code? There.
There's this issue it's giving me.
Networking issue. Let's see. Did you go? Easy. Did you get it to work?
Yeah.
Okay, so for those of you who have the console open, there's one more step where we access all the instructions that we will be using in this workshop. So go ahead and then open this link, opea.awsworkshop.io. And this is the page where we have all the instructions that we will be cutting from this page and then pasting in the console to build the application. So just have this website open on another tab so that you can jump back and forth between this console page and then just have this instruction page open. And then Easy will go through this document about what you will be doing. I think we'll only be doing module 1 today, but then you have access to this instance for the next 3 hours, so you can also try it after this workshop. You can try the other modules as well. And after this workshop, you can always open up, get your own instance on AWS and then try all the modules as well, right? So let me put that website up again, so make sure you open this one. So just show of hands again, who has the console open and then are ready to go? Okay, quite a few people, so. Okay, who else has the issue with the code? Okay, so everybody's in except one person, and then we'll get started. Got it? Okay, yeah. Okay, so Easy will walk you through the steps, and then we'll get started with building the application now. So if you have any questions during the session, just raise your hand. I'll come around and then help.
The problem with the time zone.
Okay.
Just because there's a different time zone, the machine is rejecting.
Okay.
So.
Still the same.
Suppose we are all here
So just a quick refresh what we'll be doing. We'll be deploying a RAG example using OPEA. How many of you are familiar with RAGs or RAG? Cool. So the first example, what we'll be deploying will be 40 minutes or 30 minutes. Actually deploying and learning how RAG actually works underneath, how the embeddings talks to the retriever, and how we divide all the RAG workflow. And after that should take 30 minutes, 40 minutes. We will see that RAG is great, but not for everything. So we'll see that RAG is very useful, but probably we need something most advanced, I will say. Who knows? And after that, Andreas will be presenting from Neo4j, and he will be presenting Graph RAG, which is actually, it's okay if I say an improvement of RAG?
An extension.
An extension, an extension. Okay. So we'll be going deep that, we'll be learning what is Graph RAG. How many of you is familiar with graphs or Graph RAG? Yeah, you know, nice. Cool. Great, so good audience. All right, so yeah, the last 30 minutes or 20 minutes, and we'll have a Q&A at the end. If you have any questions, the idea is to make this conversational. So if you have any questions in the middle, please let us know. We have Andreas, Katherine, Rakshith, we'll be helping if you have any problems, and I'll also answering your questions, because we are all here to help you. So, okay, so we are all here. We have this guide open. You will see something like this in the guide, right? And first, we need to configure what we have deployed. What you will have in this environment is a Kubernetes cluster already deployed for you. We usually don't make workshops or people to deploy the Kubernetes environment because it probably can take 20 minutes, and we don't want to have you waiting 20 minutes just to something to spin up. So the only thing you will have in this environment is an EKS cluster, which is a Kubernetes version of Amazon. And that's it. Yes, and we'll be deploying this example on top of the Kubernetes cluster, right? So this is a guide. It's a very educational. It explains a lot what is happening here. I will not go in all the details. So go to getting set up, and there are two options. I mean, I should make it bigger, right? Yeah. So there are two options, Workshop Studio, which is where we are doing now, and using your own account. If you would like to run this thing in your home, in your own environments, you can deploy this workshop. It has a CloudFormation stack that will install, again, the EKS cluster and all the examples for you in your account. Right. But that's not the case, so click on Using Workshop Studio. I think I will need to make the mouse bigger, if I can, those options. It's an accessibility, right? Pointer. No, it's the same thing. Okay. Don't worry. Okay, I will try to move the mouse so you can see it. Yeah, pointer size. Here we go. Yeah, the bigger. Sounds good? Okay. Okay, so you'll be here. If there's an explanation. So where you are in the console, you have your access to the terminal. So the first command is you'll be doing a lot of bash command or terminal commands. The first command you have to do is you need to set your kubeconfig file so you will be able to run the kube control commands from your environment. Just have to copy this command. And for those of you that are not working on region East 1, if you'd like to know if you're in region 1 or any other, go to your console, and you will see here that there is it says United States, North Virginia. So if you are in US 1, you should copy the command. If you are in US region 2, like your case, you were in region 2, so you should change that command, and you should put US East 2 at the end. So let's copy this command. This is something that all the time appears when you are using Cloud Shell. It's a warning, just be sure that you are copying, so on. Let's put copy paste. There is something that is wrong in this guide. Nice. Go to the cluster name when you see here. Here you go. Because we changed this workshop, so if you see AWS, EKS, replace this. I think it's OPEA EKS cluster. Just give me 1 second. OPEA EKS cluster. Yeah, okay. Yeah. OPEA EKS. Nice. You will see a command like this. AWS, this one where you copy, just change the variable OPEA /EKS cluster. If you're in region 1, leave this. If you're in region 2, change it. And you should see something like this that say added context to ARN. What it means is we put the Kubernetes configuration we have for our cluster in our terminal. So now we can run commands from our terminal. Does anyone got any error here? Cool. Are we all good? You got an error? Oh, good? Cool. Great. So now we would like to verify if we can access to the cluster. Copy, keep a scroll down on the guide. Step 3, kube control, get nodes. It's a very simple command which actually will show us which nodes the cluster has. In that case, you should see something like this. In that case, we are using a single node EKS cluster. You might be wondering why we are using AWS and why we are not using any other platform. Basically, it's because the environment we have to use. So it's, for us, it's a platform, right? So we are using the open source. Everything is open. We are using the Kubernetes version. We are using OPEA, which is open. So we are just using Amazon as a platform. Right? We're not using any service that AWS provides. We are just using it as a platform. Right? So we should see something like this. Now, switch to the module 1, which is the only module that we'll be running today, which is to deploy the chat Q&A example. The other modules, in case if you are interested, is OPEA provides this modularity. So the module 2 is to add a guardrail. If you like to check the quality of the questions and the quality of the answers, there is a module that you can add that is actually checking if it's violent or if it's biased or something like that. So this is the deployment. And there are 2 more options if you like to change your database. In this case, we are using Redis as a vector database. If you like to change it for OpenSearch, you can also change it. And if you like to change the LLM component, in that case, everything will be run locally. We are not using OpenAI. We are not using anything remotely. In module 4 actually changes the local LLM by Bedrock LLM, and we use Bedrock as a LLM as a service. But that gives you the flexibility on how you can change all of the components. So let's open up the module 1. Go to the deploy chat Q&A. There is an explanation on the architecture. We'll be using the same graphic as Katherine showed with all the Lego blocks. And this is a bit more specific with Kubernetes. Those components are actually pods, right? In the Kubernetes naming, a container is a pod. And the example of the blueprint not only gives you those Legos, because we make it simple just for visualization, gives you an Nginx, which is the load balancer in the middle, and gives you an UI. Right? So the end-to-end example is a full example when you can use it there. Everything runs within the EKS cluster, and the AWS naming is using an internet gateway to make it available to the external world. You have a load balancer on top, and you have a public URL where you can use it everywhere. and you will be using that URL to access to the UI. So run the first command. Go to step 1, copy this command. I will be explaining what is happening now. That will take a bit of time, so just copy that, go to your terminal, and paste it. What is happening here is we are installing or deploying one of the blueprints. In that case, we are deploying the chat Q&A RAG blueprint. If you go to the OPEA repo, you have GenAI examples, which are all the blueprints, GenAI components, which are each particular component, GenAI infra, multiple projects that are part of the OPEA. If you would like to deploy just an example, go to GenAI examples, and these are all the blueprints you have available to download. Now we are using chat Q&A, but if you like to use it, there is an example on agents also that you can deploy audio Q&A, documentation. And we have a GraphRag example too, which is what we'll be seeing later. Not this particular deployment, but you have an option that also deploys on GraphRags. Multimodal, text to image, these are all the examples. Chat Q&A, which is what we'll be doing, and you have these two options, Docker Compose file and Kubernetes. The Docker Compose file, and you have all the instructions here on how to deploy it. The Docker Compose file will deploy all the components, same as Kubernetes, you're using Helm charts, which specifies all the components that we'll be using. Right. Okay, so if you deploy this, let's see what is the status. You can go to the cluster, but let's scroll down to step 2 and run kubectl get pods. Copy this command and paste it in your terminal. And you should see something like this. These are all the containers that are being pulled. Each of those pods or Lego parts, they are public containers. They are part of the OPEA repo. If you go to those two repos that I showed before, you have the GenAI components, which is actually the Docker file on how you build that. And in GenAI examples, you have the Docker Compose file, which is a recipe, right? When you say, this is the container that I will be using for the vector database, this is the component, the container, or the image that I will be using for retriever, and so on, and so on, and so on. And what is happening here is I run that command, which is actually an AWS CloudFormation template, which runs underneath a Docker Compose file. We use that just because there are some rules that we need to adapt. But it's something that you can do using Docker Compose file. It's very straightforward. So you should have this. You should see this, which are all the containers. And you should see all of them in 1/1, like me. I see all of them in 1.1. Does anyone don't see these in 1.1, 1/1? You see 0, 1 in those?
Yes.
Okay. Yeah, sometimes they take more. The TGI is actually, TGI is the inference engine that Hugging Face provides. So what is happening here, you are pulling the image, which has the TGI engine, and the container itself is downloading the LLM. So that would take probably 2 minutes, 3 minutes, because it's downloading an 8 billion parameter model, which is 30 gigabytes. But that shouldn't take more than 2 minutes. So keep refreshing, and you should see it, and we will wait for that. Retriever tool. There is something we can do to accelerate this retriever. The problem with the retriever in this deployment in particular is because we are using a specific version of OPEA, the retriever is dependent on the Redis database. So sometimes when they launch all together and the Redis database is not ready, the retriever is waiting the Redis to be ready. So when it's launched, instead of waiting, it's getting an error because the Redis is not ready yet. So if you like to accelerate this, the container itself, every 2 minutes or 3 minutes, if they got an error, it will be rebooting itself. If you don't want to wait for these 2 minutes, you can copy the name of the pod, run kubectl, delete pod, and copy the name. I should put this on top, right? If you click this, we'll restart the retriever. We'll create a new pod for the retriever, and the retriever will check the Redis. The Redis is active, so you shouldn't get an error. Okay, does anyone don't have the 1/1, all the pods up?
So when I deleted a pod,
Yep.
it got stuck. I think it's not successfully deleted. Oh.
Is there starting? What is the status?
It's just not returning. Oh, there it goes. It just left. Yeah. Okay.
Cool. The delete pod command, which I already got. Oh, it's yeah, because when you run the command, it takes probably 1 minute-ish, because when runs the command, it is actually restarting the pod and starting a new one. So until you don't have it up, you have the command like waiting.
It provides no feedback that it's doing something.
Yeah.
But it is doing something.
Yeah, it's doing something. Yeah, yeah, it's waiting to be active. Yeah. Okay, so then we all most of us we have 1/1. So let's now start diving on what we have. Right? So let's go to the guide. Let's go to the second part, which is explore chat Q&A deployment. This is the blueprint or OPEA how actually devices in 3 concepts. You have the microservices, which is each microservice is performing one particular function. You have the mega service, which is actually what orchestrates, because if you have a RAG, you have some steps to follow. Right? So once you receive the prompt, you need to look for the most similar documents. You need to create a new prompt. That prompt has to go to the LLM and everything. All of those steps are controlled by one pod, which is the mega service. And the other one is the gateway, which is the Nginx. Actually, since this is oriented to an enterprise-ready deployment, in an enterprises, you always need to have a load balancer, something in the front end. You need a gateway. This deployment uses Nginx. If you like to use any other component as a gateway, you can just replace the component and you can use any other one. So keep scrolling down until the step 1. It actually creates a load balancer, right? So go to your console, click on the search bar, and look for the load balancer. Right, load balancer. Be sure that when you are doing this, be sure that the load balancer is the EC2 feature. And you will see a load balancer that was created for you. This is where you will see the UI. You will copy the DNS name. You can put the DNS name in your browser. So you copy, you put it here. Just be sure, yeah, okay. And this is the UI of the RAG application. It's not a great UI, but it's an UI. It's built on React. So again, this blueprint is meant to be an instruction, a guide, so you can put a way better UI. All right? So let's keep this command or copy your DNS. I usually copy it on a notepad, but I recommend you to copy this because we'll be running commands using this. So copy your DNS name for your load balancer. And go to the guide. The guide actually explains a bit more what is the guide. So the example we'll be running is, we would like to know if the LLM that we have is able to answer this question: what was the revenue of Nike in 2023? And we will see if the LLM that we have is able to answer to that question. So we'll be doing lots of curl or terminal commands, which is the same thing as doing the question from your browser, but we will be using the terminal. So copy this command. Don't run it. Copy the command. And there is a part that says chat Q&A ingress load balancer. You had to replace this for your DNS name that you copied before. In that case, I'm copying what I have this. So I'm copying this. And I'm pasting. Cool. Be sure to leave at the end /v1/chat Q&A. And what we are doing now is we are going to the load balancer, and we are making the question, what was the revenue of Nike in 2023? Let's copy this command, and let's run it. Here we go. Right, what you're seeing here is the streaming. You know, when you are talking with a chatbot and you see the streaming of the answer. Basically, when you are doing this kind of commands, you see the streaming line by line. So the answer, we can see the answer, or we can go to the UI and we can make the same question. We'll see that the answer is the revenue of Nike for 2023 has not been reported. Which is weird because we are in 2025, right? So the LLM, what is the LLM is something static. Right? The LLM was trained with data until 2021 or 2022. So everything you ask after that date, the LLM will say has not been reported. So it doesn't have this update. So we need to find a way to provide context to our application. Are we all good here? We all got the same streaming? Cool. So the way to provide the context is we will have a PDF, which is actually the Nike's revenue report, which is a PDF with tons of pages, which contains information about the revenue, of course. We'll be feeding that PDF to our vector database. We'll be converting that to vectors. And once we have it there, we'll make the same question, and we will see if the model is able to answer to our questions. So this is why we separate this in 2 steps. We have the pre-prompting step and the prompting step. The pre-prompting step actually will take this PDF, will divide the text in chunks, which is similar parts or parts of text. We'll convert that to vectors. It's actually what is happening here. The PDF we'll use one microservice, which is the data preparation microservice, which actually has a function that is to do the chunking or to do the separation. And we'll be using the embeddings microservice, which is the only thing that the embeddings microservice does is take a text and give you vectors as an output. And once you have those vectors representing the chunks, you will put those vectors in the vector database. And this is the pre-prompting. This is how you index the data in your vector database. So there are some explanations here. What is an embedding? How many of you are familiar with embeddings? Or how many of you know what an embedding is? Cool. So for those of you that don't know, an embedding is when you are converting text to numbers, you cannot compare text. The only way to compare text is you need to convert those text or chunks to numbers. So if we have two words, for instance, like king and queen, and woman and man, if you would like to measure or to do a similarity search or a cosine distance, we will have the same distance between queen and king that the distance we have between women and men. This way of representing the words is very useful because if you have the data represented in somehow that has a meaning or has a meaningful way to be represented, I can do search. I can look for similar phrases, similar documents, similar chunks. And that's mainly the main core when we are talking about RAGs, because we need to find similar documents, and the way to find similar pieces of information is if those pieces of information are represented as vectors. All right, so we have the question, will be a vector, and we'll be comparing the question vectors with all the vectors I have in the vector database. Very simple, very straightforward. In GraphRag will be way more advanced, but that's just a similarity search. All right, so it captured the meaning, and it also improves the model performance. The model we use here is, in that case, is BAAI. These are not LLMs. They are particular models trained to understand that representation between words and numbers. So that to give you an idea, if you like to make a comparison between apples, it will be like two representations. One representation Apple as a brand, and one representation Apple as a fruit. If you compare Apple with orange, it will be similar. If you compare Apple with Microsoft, it will be also similar. Like that kind of things is what is representing with the vectors. So I'll be rushing a bit. So now we are going to connect to all of those microservices, and we will see how this RAG process is done. Copy this command, if you keep scrolling, which is the nginx. And again, copy here the command. You will need to replace. These are the only two replacements. I mean, we will not be replacing this thing for the entire workshop. There are two things, just two things that we need to replace, which is the pod name of the nginx and the chat Q&A. So you need to get the pod name. In order to get the pod name, copy this command, kubectl get pods in your console. And you will see this is the name. Replacing your command, you will see something like this, and paste it. All right. Why am I connecting to the nginx? Because this is a Kubernetes deployment. Kubernetes is very secure on the things that you can connect within your cluster. So the only way, if I would like to test the embeddings microservice or the data preparation microservice, I don't have access to the pod if they are not exposed. So the only pod that is exposed is the nginx. So we are connecting to the nginx, and we are running commands within the nginx, because the nginx can connect to the other pods. So in that case, I'm connecting to the nginx. Are we all connected to the nginx? Cool. Great. Cool. Awesome. All right. Now we are trying to play with all of them. The first core command is to see how the embeddings microservice behaves. You copy the next command, you paste it, and basically what we are doing is we are curling, we are sending a request to the chat Q&A microservice, and we will be making an input what was deep learning. The embedding is not, this microservice is not answering to that question. This embedding, this microservice is just giving you a representation of this question. In that case, these are numbers. That doesn't mean anything to us, of course, but this is how the microservice, the embeddings microservice works. You send a request and you get numbers. But with numbers, we don't do anything. Right, so we need to actually ingest the document. If you keep scrolling down, we'll be downloading the Nike's revenue. We're downloading the PDF. We have the PDF downloaded in the nginx. and we'll be using the data preparation microservice to take the PDF, convert, get the embeddings, do the chunkings, and ingest those documents to the vector database. That takes probably 30 seconds to 20 seconds because this process is taking all the PDFs, converting in chunks, getting the embeddings, and ingesting that to the vector database. You will get a message like this: status 200, data preparation succeed, which means that you were able to put it in your vector database. I will pause for a second just to see if we are all on the same page. Yep.
So I'm kind of reading ahead a little bit, but the next step is to verify that the document is uploaded and not going to respond, right?
It's not?
It's not going to return a response, right? So you just uploaded 29 right? So
Yeah.
I guess my question is, if I upload 40 of that same document and I then query the database and I have a whole bunch of responses, what part of the tuning would be related to that?
This is an excellent question. And for that, if you have tons of documents, how RAG works, and straight talking about RAGs, is a similarity search. So if you have tons of chunks that are similar, probably the quality that you are getting when you are retrieving documents is not the best, right? Because it's always, they all talk about the same thing. So for that case, or you do a post-cleaning, or you do some kind of understanding on the data and to try to find a different representation, or you represent the data in a different manner instead of vectors. This is why you use graphs, for instance. That could be an option to solve. Instead of having thousands of documents or thousands of vectors, you have a family of vectors here that talks about something, a family of vectors here that talk about something, and so on and so on and so on. So once we are doing the search, we have something in the middle that is understanding the search, and it's saying this search has to go to this particular part, or to this particular part. And you just do the search, your question, with the documents that are related with your question. Make sense?
Follow up on that. So with the queries, this specific example going into the database, are they doing like plus or minus like a percent away from it, or is it the 10 closest documents? And if so, is there a way to measure the performance difference between those?
Yeah. We will be seeing now that when you do the retrieving, you got a score. And it's doing, in that case, it's doing the top 4, just because it's a parameter. But since this top 4 is not, we can trust in the top 4, but actually the example has another layer, which is called the re-ranker, which is a different model, which is actually rechecking the quality of the documents retrieved. And you would just have the first or the most similar document. And that is the one that was in the new prompt to the LLM. Make sense? Okay, cool. Thank you. Great question. And feel free to make any questions. I mean, the idea is to. Yeah. Okay, so we have the documents, just one document here. If you keep scrolling down, and you can get the file just to check if you have the file. I will not be running that. So now let's go to the second part, which is the prompting, how we actually do the prompting. The prompting works like this. You have the question. The question also needs to be converted in vectors. Those vectors go to the retriever microservice, which is the microservice which performs the comparison between the vector, all the vectors you have in the vector database, and the microservice and the question. We'll give you a top 4, and these top 4 will go to the re-ranker, and the re-ranker will give you the top 1, which is the most similar document, the most similar chunk. And once we have this most similar chunk, we create a new prompt, and that prompt goes to the LLM. So we are not fine-tuning. We are not doing anything directly with the LLM. We are just doing some kind of prompt engineering, and the LLM is able to understand and to give you an answer. Focus on the information you are giving. This is why RAGs are great for hallucinations and to try to limit the question and to provide context to the LLM. Right? So I'll be just using 2 microservices here. There are some commands here that this is very straightforward. So first, we'll be doing this very manually. So this is not how we actually work when we are doing this, right? So we are doing manually step by step so you can understand all the microservices, how they work. So copy the first command, which is getting the embeddings for the question. This was Nike revenue in 2023. And we will be saving this in a variable. In that case, the variable is embed question. So this embed question variable will contain the vectors that represent the question, what was Nike revenue in 2023? You can echo, but if you echo, you will see the vectors. And now we are talking to the retriever microservice, and we are given the input, and we would like to extract the similar documents. Right, so we go here, we run this command, and we save the similar documents in another variable. If you would like to see it, you copy this command, echo similar documents, and you will see the top 4 now as text. Right? So if you go scroll down, you will see divided by IDs. So this ID is this piece of text. And you will see another ID in the middle, which is another piece of text. You can export that in a notepad, and you can take a look. But we already did it for you on the workshop, on the guide, which is this is the first chunk, retrieve document. This is the second retrieve document, and this is the third retrieve document. It's top 3, sorry, retrieve document, right? And if you see in the chunks, the chunk contains some information about revenue in 2023, right? So the next step will be now to do a re-ranking on this. We would like to send just the top 3 to the re-ranker, and the re-ranker will give me the most similar. We are using 2 different models. This is why we do the similarity search, and we do like a second similarity search or cross-check, but just 1 against 3 instead of 1 against thousands or hundreds. Sure.
So is the cosine similarity, when you do your query, when you do the similarity based on what's coming from the vector DB, is it doing that similarity search on the entire document, or is it on a description of whatever the document? So is there some metadata tied to the document itself that it does the search, or the entire?
Is the chunk itself. When you're doing the ingestion of the data, you are ingesting chunks, which could be 500 characters or 1,000 characters you define. These are converted to vectors. So those goes to the vector database. But of course, goes the vectors and the metadata, which is actually the text. When you're doing the search, we are doing the search with the vector of the question and all those vectors you have. Yeah, all those chunks. If you are in a real world, when you have thousands and millions of vectors, that can take a while. And that's why you need another kind of mechanisms, which can be GraphRag. I'm selling GraphRag a lot, so but that you can imagine that it could be very challenging and also confusing. So in those use cases, you need to go to another process. But sometimes if it's a PDF, in this PDF, I think we have 100 chunks or 150 chunks. But yeah, no, thank you. All right, so now we are going to do this similarity search, the re-ranking, I mean. These commands, just copy and paste those commands, because here we are installing JQ and we are downloading some dependencies that are not installed by default in this environment. So just run it and install it. We need to reformat how we have the retrieved documents, similar docs. We need to change the format to JQ. And now we will go with those similar documents, and we will be using the re-ranking, and we will be sending the most similar documents and the question, which was, what was Nike revenue in 2023? If we copy this, we will see the score by index. You will see the first, it doesn't mean that is the first chunk, but you will see all the scores. 0.99, 0.80, 0.53, and 0.04. If you'd like to see which content you have in all of this, again, you can do echo to this, but actually I did a pre-formatting. Is the chunk that is most similar and contains both words, 2023 and revenue. So this information is what will go to the new prompt. Okay. So now the guide keeps doing some questions directly to the LLM. We will not be doing that. We can now switch to the UI. I will copy the question. We can switch to the UI. We can refresh. And if you refresh, you see that here we have the cloud with the arrow. You will see that we have the document here. And we will make the question, what was Nike revenue in 2023? If we make the question, it says in fiscal year, Nike's revenues were 51.2 billion. So it gave us the answer that we needed. Yeah, sorry. I could be lying, right? No, yes. Yeah. So actually, just to double check, I will delete the document. And I will make the same question. And the question will be, as of now, the revenue of Nike has not been reported. And the workshop will keep playing with things like context about whatever. Do we all reach to this part? Cool, great, awesome. Well, this was the part of the RAG example. This example is in OPEA. The compose file to deploy this is in OPEA, so you can deploy it and you can run it. Any questions before moving to graph? Yeah.
Maybe we answered the graph. For example, if your question was compare the revenue from 2024 to 2023 to 2024, and goes through paragraphs that are in different chunks, would your ranker pick it up or not?
That's a great question. Yeah, no. That's why you need to be something more intelligent. It's a very interesting question. I will leave you to answer because I don't want to keep selling GraphRag anymore. But yes, you need to do some more smart comparison. Yeah. Thank you so much. Yep.
This might also get answered by a graph question, but we want a more holistic understanding of what we're updating. We're only uploading chunks, and then that's all it's looking at. It might be related to this question where we're looking at multiple manipulation of it. If I instead asked, give me or how was the overall health of Nike's financial report, it's not going to be able to return that either, right? You need to actually understand the document process.
Yeah, and you can actually, I mean, it depends on the LLM you are using too. If you use a reasoning model, the answer could be a bit better. But that depends on the use case, what you are using, what information you are using. For instance, we used to show the same example when we talk about Python. How was Python influenced other languages, or what was influenced by other languages? And if you make the similarity search, the model will say when it was created and what is Python, for instance. We'll give you something like that. But if you like to really understand how is the connection between Julia and JavaScript and all the others, and you would like to have an answer on that, RAGs would not give you that answer. With a graph, yes. Yes.
So this is something that the solution is going to be describing soon, that you're not selling us, but you're absolutely selling us that solution.
And that came to our minds. So it's it's fine for this, but what happens if I need more understanding of it? My data is not as simple to compare. If it's a comparison search that you are doing something very simple, I would like to have a summarization of this. Just give me what is this, or you're asking something instead of reading a paper, you can do a graph, a RAG, right? Because it's very simple.
You mentioned reasoning models. So what you're describing is a potentially more elegant solution than just doing things in a loop, like local queries and then summarizing at the end?
Probably. I mean, of course, I hate saying it depends, but can help you. Yeah. Thank you. Thank you so much. Great questions. Okay. I will not keep selling GraphRag anymore. So now you need to talk about GraphRag because there's an expectation about it. Thank you. Thank you so much.
You set a high bar. Now I've got to
All yours.
actually sell GraphRag.
All
Now
yours,
that you've
man.
been selling
All
it.
yours.
Oh my gosh. All right. So hello everyone. I am Andreas. I'm ABK from Neo4j. Neo4j, have you heard about it? It's a database company. It's a graph database. We love the GraphRag. I'm here to talk to you about the GraphRag. First, I'm here to figure out how to get my display mirrored. This is the true challenge of technology. Not AGI, AV. AV is the real challenge. Okay. I have a lot of material I can go through, but I really want to go through just the basics and then kind of in the time that we have, really get into any kind of questions. So if you guys have questions as I go through this stuff, ask them as I go through it. Don't wait for anything. Okay, a brief introduction to GraphRag, but first introduction to graphs. In case you're not already familiar, these are what would be tables potentially. This is a very classic scenario, I'm willing to say, that in every relational schema in the world, something like this exists where you have two tables and then a third table in the middle that is the join table that connects them, right? This happens everywhere. Okay. If instead of thinking about joining these tables, sometimes the access pattern that you're actually doing is looking for a single record and then going through the join table to get to the other side to find what records are related, right? You're not doing aggregate queries across the joins. You're just trying to find all the detail, for instance, right? So if you think if this was a person table and an asset table, in the middle you had the person asset table, and you do the joins across, and you just kind of highlight those records. You can see where maybe I'm headed here. Get rid of all the other records and just draw the arrows. It kind of looks like this. And visually, if you just kind of squint, you can turn all those join tables into what we would call in the graph world relationships. And that mapping from like everything that was a record in a join table is just a relation in a graph database is a fair place to start to think about what a graph database really is. It treats that join table basically as a first-class citizen, and rather than having to calculate any joins, once you've found a person, you can just follow the relationships through to all the things the person owns. So we're effectively optimized for those cross-query types of joins. That's the basic idea. Everyone already gets that though? You've already kind of heard about Neo4j. So let's keep going. We've got a query language that goes along with this. The fundamental idea about the query language is doing pattern matching. And because we all love regular expressions, this is like being able to do regular expressions but with data records, with all the kinds of things that that entails. You can have repetitions that you want. You can have chunks of a pattern that repeat some amount of times. You can describe patterns that turn into T's and Y's and all kinds of different shapes. It is all just pattern matching is a fundamental pattern, fundamental access. This is what graphs do. Turns out this is really useful for doing stuff with GenAI and LLMs, because GenAI likes to think about natural language. And even as you look at this here, you can kind of read this and it reads like a sentence. Match a person that owns some assets. You could imagine typing that out. This is really easy for LLMs to actually understand and actually generate this kind of code the way that they can also generate Python code. So it's a really good match for natural language. That's out of the gate. Question though?
Owns, is that automatically created, or do you have to manually?
Oh, I love that question. So it is manually created. You can auto-generate it as well. I'll get into that a little bit later, but like a project that I'm working on right now is having an agentic approach for knowledge graph construction, where you just kind of analyze the data you have and decide what kinds of relationships should exist. And so you can do a pretty good job of actually asking an LLM to do the work with a bit of guidance. But this model that I have was built by hand. The examples I have were kind of built by hand in kind of classic modeling fashion. So fundamentally, GraphRag ends up being just RAG, where the retrieval part is a graph. We already went through basic RAG. This is the idea of basic RAG.
The problem is that the LLM doesn't have access to it only has public information. There might be private information it doesn't have access to. Somehow you have to supply that to it. That's what RAG really does. Great. Bunch of chunks in standard RAG. To think about graph RAG, this is the simplest version that I can show for what graph RAG is. If in addition to the chunks, you had some way that you connected the chunks to each other. And here I took one technique where, given a chunk of text, there's this idea of doing named entity recognition, where you look through the text and you say, hey, what are the people, places, things, or other things I might be interested in inside of this text? Pull those out into separate data records, and then anything else that it refers to that thing, let's say you find that ABK, me, I'm in one of the chunks, pull me out into a separate node, now there's an ABK node. Any other chunk that talks about ABK also will point to the ABK node. What that does is give you connections from the chunks to other chunks that refer to the same kinds of things. That's the fundamental insight. Chunks no longer live by themselves. You find some way to connect them to other chunks that mean something similar or have relevance. Okay. So in this example, like if you just did vector similarity search, and depending on what the user's question was, they just found chunk 2, that might be good enough to answer their question, but often that's not enough context. So an easy thing to do is just to kind of reach out through the graph to other chunks that are related to that chunk, but not similar to the user's question. And that's the key insight here. Sometimes based on the phrasing of a user's question, there is not a very clear mapping into actually what the answer is. This particularly happens when you have naive users who don't know what to ask for. So what they say isn't necessarily what they mean, but they mean something close enough. So just by expanding the context a little bit, you can already provide them with better opportunities for getting a good answer. One more baby step forward. Okay, now I'm going to go a little bit deeper into this kind of rabbit hole of why graphs are interesting. If you think about vector similarity search and the idea of doing chunking, and you just say, like, for any chunk that you've got, let's just say each chunk can answer one question. So you've got 10 chunks. Those are 10 questions that can be asked because similarity search is basically a lookup. You're just saying, hey, there must be an answer here somewhere for this question. Look it up. Find me the chunk that's relevant. Give that back to me. So if it's a one-to-one relationship, that means it's linear. Number of chunks equals number of answers. Also number of questions, right? Awesome. But with that same amount of data, if you just had 10 chunks, and you considered pairwise comparisons against the entire chunks, now it's 10 times 10. You've got 100 pairwise combinations that are possible. It's not just that they're pairwise combinations. For every pairwise combination, you think, how are these two chunks related? This is the brute force approach, but you can do this. So in an upper bounds, you went from only 10 answerable questions. Now you have potentially up to 100 answerable questions. Now, in reality, it'll be less than that. Some of the chunks are going to have nothing to do with each other, and that's not worth keeping, but that's okay. But as the upper bounds, it's pretty promising. You can take this one step further. Since you're comparing just pairwise, you can do other subsets of the graph. Subsets of just the vectors, I'll say, right, of the chunks. There's this idea of a power set, which is all the subsets of a set. The power set, so if I go back here for a second, so if this is n squared, number of answerable questions, right? With a power set, it's now 2 to the n, number of answerable questions. It is all the subsets of that set, potentially could be meaningful for answering somebody's question. Each time you find any of these kinds of subsets, what you do is you either save that's something interesting, but you also can add some information about it. So when you're doing pairwise, you can say, how are these two things related? Add information about how they're related. That is useful to know. In the subset version of this, you look at all the subsets and say, okay, given this subset, let me just do a summarization of that. Now you've gotten like even a broader scope potentially, multiple levels of broad scopes that can answer questions from that same base 10, initial 10, I should say, set of chunks. This is the promise of GraphRag. Everything within GraphRag, and there are lots of research papers about this, we have lots of techniques that we use for doing GraphRag, basically explores this space, tries to figure out for any given user's question, what is the subset of all the potential sets of things you've got that is useful for answering that question. Find just what's relevant, not anything else that's fluffy, return that to the LLM for getting an answer, and you can get even better answers, broader scoped answers, and also all the way having very finely tuned answers. Does that all make sense? This is the basic idea. Okay, I'm going to skip forward through this to the end part of it. This talks through the idea that within GraphRag, the other nice benefit of being a graph is that it's pretty easy for us to connect anything together. If you just have unstructured data, we can turn that unstructured data into a graph. If you have some structured data, you can connect the structured data to the unstructured data. And then you have some mixed data, so that now you can do vector similarity search with some pattern matching, or you can do some pattern matching that then finds some text documents. You can do summarization on any of the different levels. And now the possibilities are literally just through the roof. This is the problem space, not only that you're expanding over the chunks, you're now incorporating structured data, which in most enterprises is kind of by definition, that is the value that you have in your data. If you've put it into structured data somewhere, that is the most important information you have in your enterprise. So attaching unstructured data to the structured data usually ends up bringing out most of the value that you're looking for in the unstructured data as well. If you just look through unstructured data just kind of open-ended, there's a lot of fluff. There's a lot of stuff that is not really relevant. By kind of constraining what you're constructing with the structured data, you're going to get better value in the overall data set that you've got. Okay, now I'm going to step forward into an example. Yeah, plenty of time. Okay, and actually this is nicely teed up by the Nike example. I'm going to carry that forward a little bit. The SEC, which I don't think Doge is cut yet, is here in the US, the Securities and Exchange Commission looks after our financial markets. There's two documents that I'm interested in from the SEC. There's Form 10Ks and the Form 13s, and I always forget which one is which. The Form 10Ks is what publicly traded companies actually have to file. This is their quarterly reports, what's their current business risk, all those kinds of things. On the flip side, the Form 13s are for institutional investment management companies. So companies that invest like, I don't know, I think it's like 10 million plus or something, you have to file and let people know, hey, we've just bought a bunch of stock in Intel, because go Intel. Cool. When you're doing knowledge graph construction, I always say, and to your question earlier, this is becoming automated a little bit, but if you're doing it by hand, start small and let it grow over time. There is the possibility, and it's a very tempting possibility within graphs, to just kind of put everything into the graph and let it kind of represent the entire world. That's certainly possible, but maybe not always helpful. So start small and evolve over time. So minimum viable graph, create some stuff, figure out what's interesting about that stuff, make sure you connect it to the other things you already have. With the Form 10Ks, this is the standard vector similarity thing that you do really. Take the text data, chunk it up, do the vector embedding, and to make it a little bit of a graph, you can connect them in sequence, so now you have a linked list. Maybe not the world's greatest graph, but it's at least a graph, okay? You have to start. That's my minimum, right? Minimum viable graph. Okay. This already gets you a little bit of benefit though. So often when you're doing chunking, one of the challenges with chunking is figuring out the right chunking strategy. And like, okay, how much chunks should overlap? Okay, it's gonna be 2,000 characters overlapping by 100 characters. Maybe that works, maybe that doesn't. When you have a linked list, you can dynamically expand. You'd be like, you know what, I don't have enough context here, let me expand out through the linked list, front and back, and that's pretty easy to do. Small benefit, but it's, the best I could come up with for linked lists. But this is where it gets a little bit more interesting. We know that all of these chunks came from an original document together. So one nice step you can take is, for all the chunks that came from a single document, create a node for that document that represents where it came from. So here it's the form node. Recreate the form node, and rather than have all the text of the form node on the form node, so all of the text that is from the form on the form node, do a summarization over all the chunks, and store that summarization in the form. Now you've got two levels of queries that can be run. Now when you do vector similarity search, if the overall summarization of the form is useful, then you get an answer from that. Otherwise, you might get a chunk because it's much more specific. This idea continues, and we'll come back to it. You can end up doing summarization on all kinds of different sizes and shapes of the graph that are useful for targeting different kinds of questions that people ask. And the one caveat that I'll say there is that while that is useful, it is also expensive. And so you should think carefully about how much of that you want to do before you store summarizations about every possible combination of things. Okay, I'm going to flip over to the structured data side for a second. In the structured data, we don't really care about the text about these institutional investors. What we really care about is the dollar amounts of who they invested in and how many shares that was. So this is the simple part of the graph for that. We've got some management company that invests in some stocks, and they have an owned stocks in relationship to the company that they've invested in. And then, because we don't really care about doing similarity search for their company names, we're going to do a full text index backing that as well. Because we're a normal database, you've got all the usual kinds of indexes, full text, geospatial, you can do vector as well. Cool. Oh, and speaking of geospatial, the other thing that's very nice with graphs is because you've got a geospatial index, so if you actually have locations, you can put that into a geospatial index and do nearby searches and things like that, so you can find not just financial reports, but financial reports for companies near me. If that's the thing you want to find out about, you can do that. And you can also turn that into a part of the graph topology. So here, rather than having just the locations on the companies, I've pulled those out into separate address nodes and connected the companies to those address nodes. Now you can just do pattern matching to find investment companies that invest in businesses that are near to them because they share the same address. This simple little pattern, while it's not as useful here for looking into investment firms, is the basis of what we do for doing fraud detection. Just finding where there are coincident patterns of locations, names, and people around a company. To mix the data together, there's this little highlighted yellow bit here where the company that was part of the structured data from the investment gets connected to the company that filed the form. And now you've got structured data on one side, unstructured data on the other side, and now you can do queries that cross both of those data sets as if they're just one thing that you can ask questions about. So now you don't just have vector similarity search, you can do vector similarity search that includes structured data as well. So you can ask interesting questions like, oh wait, I don't have the question here, but like if you asked about Nike in the report might have some concern about their supply chain, like that they're sensitive to changes in the global economic climate and they're restricted on shoelaces. I don't know. So you could ask a question about like, okay, whose investment portfolios are exposed to a problem in the supply of shoelaces? Because maybe you've got some information about that. The shoelaces problem will get you to the companies that have a problem with that, but then you can trace back through the graph to find the investment companies that have invested in those companies, and now you know who's exposed. Good to know, right? Do that with a vector search. Okay. This is what we just went through. This is a very quick tour of like starting with both unstructured data and then moving into the structured data, combining those all together into one data set. This is, I would say, like the kind of foundational thing that people who use Neo4j for doing GraphRag, they do at least this, and then they continue to elaborate on what they do with the graph and also what they do with what we call the lexical graph, which is the text part that has vector embeddings. Some examples of that I hinted at a little bit, like while you have these chunks, you might do a summarization on the document level. Once you pull out these entities, you can also do what's called community detection, which is taking advantage of the layout of the overall graph to find areas of the graph that are highly connected versus less connected. And the highly connected parts, roughly you would end up calling a community because they must have something in common. You take that community, generate a summarization of that, and now you've got topical-based summarizations in addition to the structurally-based summarizations. Any of these techniques might make better or worse sense depending on what the data set you have to work with. The other thing that I've done here, oh, and I did mention this along the way, but while doing named entity recognition is very helpful for very open-ended kind of text that you might have, when you're forming graphs out of unstructured data, it's also useful to take advantage of regular expressions. I'm going to bring that back up again. If you know there are URLs or citations, if you have legal documents that you're looking through, don't ask the LLM to find the citations. It's going to be in a very predictable pattern. Use regular expressions, find those, and do the cross-linking to have very richly connected documents. Aside from the community detection, once you have connected documents, you can even do things like PageRank, which helps all the way back to like when you have lots of documents that have high similarity scores. How do you figure out which one's the best one? If you ran PageRank, you'd find the one that's the most connected one, or at least the most cited one. So that can help actually do the ranking for even vector similarity search. Okay. And that was with 5 minutes to spare. I'm going to open up some questions first, and then you can applaud. Go ahead. Oh. Yeah, try again.
So this seems to live or die based on how efficient your graph implementation is. It seems like it would be, for most of the implementation you're talking about, would be very expensive to insert and delete. But then, actually reading from it would be incredibly performant. Is that accurate?
Yeah, so like if you have data that changes a lot, the most expensive part is like doing things like community detection. If you add data and you have to recalculate communities, that gets very expensive. So an alternative to that, rather than kind of doing the pre-calculated communities, is you calculate communities on the fly and then do summarizations over those communities. Because the summarization sometimes isn't that expensive, so you can do it on the fly instead, rather than trying to do it in anticipation that somebody might ask a question that they never ask. So that helps mitigate some of the cost.
In a similar vein to that, with other things, for example, like Perplexity or other services like that will go out and search and find that information, which could definitely be augmented by something like Graph or GraphRag, right? Is there already a place that's looked into doing things like tags or word clouds or any of the other things we already do to look at that information to better optimize how we're putting things into our GraphRag? Or is this still very much an unsearched field?
I apologize. I guess I'm not quite sure on the question. Is it like, are we taking advantage of tag clouds for enhancing the graph structure, or for?
Yes.
Okay. Yeah, so in terms of like how you actually form the graph, I'll say that is highly dependent on the actual domain and how people approach it. This is the worst kind of answer, like you gave it before, and it's unavoidable. It depends on what you're starting with. But there's a rich set of literature exploring different ways of constructing graphs in different ways, optimized for different domains. I would recommend there's a Hugging Face space called GraphRag that has a great collection of archive papers that explore knowledge graph construction and also GraphRag retrieval techniques. And also things like multi-agents and how you use those for doing query planning from the LLMs perspective. So I would say that everything's being researched, including what you're mentioning, and there's some good papers on it. Yep.
So for regular RAG, we may have a linear mapping between questions and chunks, but the answer is more deterministic, right? For LM, I think for graph RAG, do we have a concern if we feed LM too much information, it may hallucinate?
Oh no, I think the opposite is true. So with GraphRag, you have the opportunity to have much more fine-tuned, or that's the wrong word to say, much more well-focused information than you do out of just doing vector search. Because if all you're doing is handing a bunch of chunks back, you're handing back the 5 top chunks, then within those top 5 chunks, unless you have some way to actually refine what's there, you're likely to get some noise. And LLM's hallucination gets worse the more noise you have in the context. As a kind of not just thought experiment, but experiment you can run, like you can push an LLM kind of off the trail by saying things like, hey, talk like Yoda, and as if you were answering a question to like I'm a 5-year-old or something. The more kind of context you give it and instructions you give it pushes the probabilities that it's going to answer things in a particular way. Noise has that effect as well. So rather than the noise saying talk like Yoda, it's going to push the probabilities away from the actual answer and give it the opportunity for hallucination. So it's super important to give just enough information and have it be very well focused. The graph actually gives you the opportunity to have better focused information if it's the chunks or if it's not the chunks. Like in the data that gets pulled out of the graph, pulled out of the text into the graph, you can think about those entities and the relationships among them as being a compression, just kind of a distillation of the information from the raw text. Raw text has all kinds of extra information in it that's not particularly helpful.
Yeah, and even you can see in the example, if you see the chunks when we do the Nike example, if you see the most similar chunk, if you read that, has the information of the revenue, which is 3 words or 1 word, and you have 2,000 or 1,000 characters that talks about different things.
Yeah.
talks about any other thing.
All that extra stuff gives the LLM more opportunities to say something
Exactly.
silly.
Yeah. It's like steps. The LLM itself hallucinates. RAGs can help a bit, helps a lot actually, and GraphRag gives you like this specific information that the LLM has. Instead of giving a big chunk, you have the chunk with all just information you need.
Cool. Okay. I'm happy to chat more. I'm going to give a demo of my agentic knowledge graph construction work in progress at the Linux Foundation AI and Data booth over in the wherever we are. Where are we?
Yeah, in the solution showcase.
Over there,
I know.
Solution Showcase.
Find a table.
Thank you, everyone.
Thank you. Thank you so much.